Our nation has a proud history of taking technological leaps. The privilege of going to the fridge for a cold drink? You can thank an Aussie for that. Need to hang some shelves on the wall? Tip your hat to Arthur Arnott for inventing the electric drill. And it's not just these features of modern living that we can lay claim to. There's also the underwater torpedo, the pacemaker, bionic ear, and even the notepad. But it may just be that the most incredible technological feat of all is lying in the heart of the Queensland desert.
Welcome to Longreach. Your mobile phone is a little reach. You may now switch flight mode on.
I'm visiting the Jindalee Operational Radar Network, or JORN as it's known to its friends. It can see across thousands of kilometres without needing line of sight. This proudly Australian technology reveals the innovation and perseverance of our nation. In this episode of Technically Possible, we're going to meet the people behind this success story and discover why JORN is Australia's technological crown jewel.
And it's kind of confronting. You know, you could look down and see goannas and, camel running beside you in the car. And then you look up and you see this 21st century thing, literally in the middle of nowhere.
Hi, I'm Lily Serna, and welcome to Technically Possible, a podcast produced by BAE Systems Australia, taking you into Australia's defence industry to meet the people transforming technological hopes and dreams into reality. The Jindalee Operational Radar Network is perhaps Australia's greatest defence triumph. But it didn't just happen overnight. The JORN story began in World War II, as Australia was facing its largest military threat.
We're very lucky to have modern inventions such as long-range radar and satellites and so on if we want to safeguard our country, because in early 1942 we learnt the hard way.
This is Dr. Tom Lewis, a military historian and former naval officer.
Singapore fell 15th of February 1942, a British outpost and a bastion of the Empire, a stronghold, and a lot of our soldiers went into captivity without firing a shot. And we're all alone in this big country at the bottom of the world, beset by enemies.
4 days after the fall of Singapore, on February 19, 1942, Japan mounted the largest ever single attack by a foreign power on Australian soil.
They came south with speed, rapidity, ferociousness and bravery, and did a tremendous job of carrying everything before them. And they launched a surprise attack on Darwin and killed hundreds of people, destroyed 11 ships, 30 aircraft, and all because we didn't have what we nowadays call eyes in the sky. We simply didn't know they were there 300 kilometres or so off Darwin until they actually arrived over our city.
It was after this attack that Australia realised it had to develop better technology to defend its large stretches of coastline. Radar was already being developed internationally, but with the evolution of the Cold War, research into radar technology really took up speed in Australia.
In those days, the radar wasn't very long range. So if you want to see the enemy, if you want to defend, you need to see. The Mark 1 eyeball, as you call it if you're in the ADF, in Defence Forces, is only got a limited range. If you're in an aircraft at height, you can see maybe 50 kilometres on a good day, but they're little tiny dots coming towards you, and you've got to put your aircraft in between them and the target. So it's all very difficult.
And so the hunt was on to develop a radar system that could look beyond line of sight. In the 1950s, scientists started working on a way to see beyond the horizon by bouncing radar signals off the Earth's ionosphere. This is part of the atmosphere that has been ionised by solar radiation and had been used to assist radio communication since the 1920s. But its application to radar was something new. Dr. Bruce Ward is a Defence Science and Technology Honorary Fellow and an Adjunct Professor at the University of Adelaide's Space and Atmospheric Physics Group. He began his journey with JORN around 45 years ago.
Initial experiments were made in Melbourne and they didn't work, and the reason was they were using a pulse transmitter and they didn't have enough power, so that led them to believed that they needed to use a bistatic system where you had continuous transmissions, but the receiver and transmitter site had to be separated by something like 100 kilometres. So an initial experiment was conducted between Derby and Mirricata on the Woomera Rocket Range to show that the signals were sufficiently stable, and that led to what was known as the Stage A system. So the Stage A was a simple prototype to demonstrate to the powers in Canberra that you could detect aircraft. It involved a transmitter site 100 kilometres out from Alice Springs and a receiver site just out of Alice Springs. And those two systems just provided a single beam looking along an air route.
While these early experiments proved the technology was possible, those in power had to be convinced.
There was considerable opposition at the time because it was thought that it was a technology that mightn't work and might not be accurate enough. Over-the-horizon radar provides relatively cheap, broad area coverage, but lacks some precision. Airborne early warning aircraft provide considerable precision and control of tactical aircraft, for example, but are expensive and are limited in the area they cover. The final decision was made in 1974 to provide funds for what was called the Stage B radar, which was a principal demonstration that you could reliably detect aircraft targets at long range.
It was from here that the world-class Over-the-Horizon, or OTH radar network, was developed. It was set to become the technological holy grail for the new generation of engineers. Liz was one of them.
We should be really proud to have that sovereign capability here. I think it's been such a long-standing project and one that's only improving in terms of its capabilities with every phase. So, yeah, I'm really excited to be part of the Phase 6 side of it.
Liz is the lead for the JORN surveillance software team.
So normally radar is like line of sight radar, but JORN, it's special because it uses what's known as the ionosphere to bounce signals and reach targets that are much further away. So that's really important. It gives us this sovereign surveillance capability to monitor what's going on around us and keep us all safe. So in my team, we develop all the software that interacts with the hardware at our 3 radar sites across Australia to help achieve that surveillance goal. We also develop what's known as human-machine interfaces, or HMIs, and they help our maintainers at those radar sites to be able to maintain and interact with the hardware. And they also interface with other HMIs that the RAF personnel use to actually operate the radars.
Before leading the software team at JORN, Liz was working in the field of maritime sonar.
I just knew of JORN as this project that had been going on forever, and that it was one of the sort of success stories and something that I really was interested in and wanted to know more about. But yeah, at that point I didn't know anything about ionosphere or radar particulars, so it was interesting the way that defence always gives you these different opportunities you don't expect, or a direction that you don't expect to go in.
Dr. Gordon Frazer is the CEO of Frazer Lab, a company that specialises in high-frequency, or HF, technical services.
Perhaps the maddest thing of all is that I was kind of born for it.
For 12 years, he worked directly on JORN as the research leader for HF radar in the Defence Science and Technology Group. He's been widely recognised as a major contributor to JORN's success.
When I was a kid, my father was an amateur radio operator, and his radio room was next to my bedroom. And this was through the period in the 1970s when the Soviets at the time were operating their first generation of over-the-horizon radar. They were quite careless in the way they used it, and it interfered with all the amateur radio communications. And so my dad had come screaming out of his room, bleep, 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 about this thing called the woodpecker. That was the colloquial name given to this Russian over-the-horizon radar. I had this childhood memory of over-the-horizon radar, and it kind of stayed with me. And then I went to university, I did electrical engineering. I then had an opportunity to do a PhD as a cadet through DSTO, and that was in the HF radar branch at the time. And I just loved it. I've just absolutely loved the whole thing.
Dr. Frazer says the OTH radar is a perfect fit for Australia. This is because with the technology, there is a minimum and maximum range you can see.
And so you can't see 100k or 200k, but you can see 800k or 1000k or 2000 kilometres away. So you need to have a country that's deep enough to be able to stand this thing back from the regions that you're interested in looking at. And obviously Australia fits that to a T. And so does the US, and so does Russia, and so does China, and so does France, actually.
The 3 JORN radar sites are in remote inland locations in Australia. One near Longreach in Western Queensland, another outside of Alice Springs, and the other in outback Western Australia. All 3 are controlled by a command centre in South Australia.
Each radar is actually 2 locations, one for a transmitter and one for a receiver, and they're about 100 kilometres apart. But to go to a JORN site, the most remote is the one in Western Australia, near a town called Laverton. And you fly to Kalgoorlie, which for many Australians is a remote destination in itself. And then you drive about 2 hours north and 2 hours east. And that gets you to Laverton, and then there's about a 50k drive to either the transmit or the receive site, depending on which you're going to. So you arrive at the site having gone through this quite extensive travel, both in air, arriving at a remote location, and then driving through the true Australian outback. And then you arrive at this thing that's this most marvellous piece of engineering. It's physically very large. And so, as you drive up, it's not just a few small buildings, it's this giant facility. So you arrive there and you're struck by the fact that how could a nation build such a thing in such a remote place? There'll be kangaroos, there'll be red dirt everywhere. You get there and you're really taken aback by what you've come to see. And then confronting, that people like yourselves before you have built this thing. It is a mystical experience. So it's that little kid again, years later.
Yeah, well, my wife does think I come out here for a 2-week holiday. So you have fun out there and you really like it, which is partially true.
I'm driving just outside of Longreach with Brad, the site lead at this particular JORN site.
I love my job. I enjoy the people I work with, but I certainly love my job. The lifestyle works really well for me, and I love working around the technology. And I think that's pretty rare, that people actually really enjoy what they do. But I certainly enjoy it, certainly enjoy the people, certainly enjoy the organisation we work for, and certainly deliver the product that we deliver to the customer. With a lot of these defence assets or capability, a lot of them tend to be offshore technology that we import. Sometimes we modify it to suit our needs, but JORN itself has really been developed, built and run in Australia. So I think, it certainly is something that I think the business should be proud of.
It's silent. It's completely silent. There's no moving parts. So you roll up and nothing's moving, nothing's spinning or booming or crashing. There's no smoke coming out of anywhere. So it's quite static, but it's just there. And it's kind of confronting. You could look down and see goannas and, camel running beside you in the car. And then you look up and you see this, 21st century thing, literally in the middle of nowhere.
The transmitter site is big power engineering. It's got a large number of high power transmitters feeding into what we call log periodic antennas. These are antennas that are quite high and quite long. The receiver site consists of some 400 plus receive elements, antennas, along a 3 kilometre site. Looks like from the air an aircraft runway. But it is marked with big white red crosses to show that it's not serviceable runway, so you can't land an aircraft. The receiver site then has a building with receivers and signal processing computers. And then at Edinburgh now, the 3 radars are operated remotely. And so there are crews at the transmit site and the receiver site for maintenance, but all of the operations occurs at the Edinburgh Air Force Base.
Brad and I are standing at the high-frequency array when he introduces me to Lee. Lee came to work at the Longreach site about 6 months ago from the Navy.
I'm enjoying the work. People are really nice and always happy to help out, whether that's learning about the technology that's out here on the radar or just day-to-day life. And 2 weeks on, 2 weeks off for me suits really well. I'm hoping to build a career out here in the coming years.
For Brad, the best thing about working for JORN is a strong sense of collaboration between the teams.
Yeah, look, the thing with this program is we've got a really strong relationship with the customer, being the RAF and Department of Defence. We've got a great relationship in the engineering side of the business who are embedded with the Commonwealth. And it's a really strong team focus, and I think that shows up in the results we get with our capability, our availability. So I think it's something that generally Australia should be really proud of what we do out here and how we work. We're very efficient in what we do. We're constantly looking at ways we can, reduce costs, reduce overhead, deliver the best product to the customer, and that's genuine across the whole organisation, inclusive of the RAF and the Department of Defence.
In the 1970s and 80s, as JORN was being developed in Australia, the US government was doing its own OTH trials. Bruce Ward explains.
The circumstances, we have a collaborative arrangement with Canada, the US, the UK and New Zealand, and through that the US became aware of the work we were doing and they extended an invitation to collaborate. Collaboration has continued with the US over many years, both with the US Navy and US Air Force.
As time went on, the US started developing similar OTH systems, but Australia's JORN remained the gold standard.
There were a number of features about the Australian system that, in our view, are more flexible and more capable than some of the US systems. We often had to work with relatively small budgets, certainly compared to US budgets, and we had to make do, but there were a number of really innovative features that were present in the Jindalee radars that weren't present in US systems. Fully indigenously developed and meeting a real need for the defence surveillance capability.
One particular challenge facing OTH radar networks are fluctuations in the solar conditions that fuel the ionosphere, as Gordon Frazer explains.
So it's hard to decide whether your equipment is limited by the ionospheric variations of the day or whether it's by equipment performance limitations. And to some extent, that's actually a bit of secret sauce that Australia has, that it's understood that balance between equipment fidelity and naturally occurring ionospheric variation. I think we've got that better than anyone else. And so it means we can kind of do things that perhaps others, even others with these radars, may not expect that you can do.
When Dr. Tom Lewis started working with JORN, he was taken aback by its size, capabilities, and the fact that it was homegrown.
I well remember working with JORN at RAF Base Edinburgh and being so impressed by the fact that we had something that was so Australian and it was so huge and it was so capable. And of course, it was developed in cooperation with our defence partners overseas, and we're very grateful for that. But one of the things that struck me was it is so capable, yet it's so hidden. It's in the middle of Australia. Australians don't really go and see it. It's not a tourist attraction. Yet if you look online and you read up about it, you think, this is really, really impressive. We're very lucky to have it.
Liz agrees.
I think it's just such a unique ongoing project, and if you come into our team, you've got people who've been SMEs on the project, subject matter experts for the last 15 plus years who just know all the ins and outs of JORN, and then you have these new starters who come in going, oh gosh, what's going on, this is so overwhelming, but as they start getting their head around it, they're like, wow, this technology is so cool, and the SMEs are all there to train them up. Like we have these lunch and learn sessions and sharing of knowledge, and it's just so collaborative. So, we do a bit of work or a bit of coding and then they'll add to that coding and we share between each other, and it's just a really good relationship and one where we both just really want to see it succeed. It's just a really positive culture and an important technology that we're all really passionate about.
For Gordon Frazer, the success of JORN has been largely determined by the commitment of those who have worked on it.
We've been taking this technology seriously and continuously for about 5 decades. And we've had continuity of both knowledge development, testing of systems, and development of workforce and transfer of knowledge across generations. Now, most countries haven't. They've sometimes started and then stopped and then had to restart. And they've done so without that continuity. And, you don't move forward if you don't work on something. You don't move forward if you don't pass generational knowledge. And so I think that's a real power and kind of a foundation as to why we lead. I guess the other half, so that's about the technology, the science of OTH radar, but even operationally, even the use case of these things, we've been running them operationally for 30 years now. So the Air Force, the operators, have a couple of generations of experience within their world as well. So put it together, 5 decades of the science and technology, 3 decades of operational use, and continuous support through that period. I think that is the reason we are the best in the world.
And the next chapter is an upgrade, which will ensure that JORN remains modernised and maintained into the future.
And occasionally you have to do a big job of that. Think about your own personal house or your car or something. For a while you can do little jobs to just keep it going, but occasionally you have to do something major. So part of so-called midlife upgrade is to make sure all those major items that now need some serious work done, get done. But because the technology embodied in something like JORN, it's almost the same technology as you see in your iPhone or your Android phone. Obviously, it's not a series of iPhones, but it's the same technology around electromagnetics and signal processing and integrated circuits and so forth. So in the same way that your phone changes because technology changes, that is true of the radar as well.
The big question that remains is what will be the future of JORN? If the sky's the limit, perhaps we may see even further.
The future of JORN is very exciting. I'm delighted to be part of it. The current system is already very sophisticated. I've described how it's world leading. In the current radar jargon, so the jargon in the radar communities, it's a cognitive radar. So that's a kind of a groovy word, but that's probably the first of the true cognitive radars. But there's even greater opportunities going forward. So what are those? So there'll be higher performance, so see smaller targets at longer ranges in more difficult ionosphere conditions. And with the techniques of cognitive radar and machine learning, we can close the gap between a commander's intent and how the radar is set and operated. So imagine if a commander could look at a map and his mind is interrogated and the radar is immediately configured and executes his intent or her intent. Now, that is not how it is today, but it is how I would like to make it.
He's certainly come a long way from that young boy listening to his father on his amateur radio. But for Dr. Frazer, the magic of technology like JORN has never gone away.
That imagination that 13-year-old kid had has just played out all my life. And in fact, maybe my friends call me childlike even today because it's that same wonderment every single day when you work in this field. We work with Defence and the members of the various services, male and female. They join because they have this commitment to the nation. And as a scientist sort of beside them on many occasions, you look at them and see what they bring to bear and you think, well, I probably couldn't do that. I'm no black ops sort of, ninja dude kind of thing. But to know that knowledge about linear algebra, knowledge about probability theory can be brought to bear in the same way that they can, raid a building. It means that there's a place for you contributing to the nation and you can do it beside people who think the same way and have, really committed their lives to it. So it's a wonderful, wonderful role to have, I think.
Well, Gordon, linear algebra was one of my favourite subjects at university, and I am so glad that linear algebra can play its part in protecting the nation.
JORN, Australia's technological crown jewel, protecting Australia into the future using Australian ingenuity and innovation. Thanks to all those we spoke to in this episode of Technically Possible. The series is produced by BAE Systems Australia and Audiocraft. The music you heard is from Epidemic Sound. If you haven't listened already, you can find all previous episodes of Technically Possible on your favourite podcast player. And let us know what you think. Find us on social media at BAE Systems Australia or drop an email to tppodcast@baesystems.com.